Have you ever looked at a mirror and wondered what you're actually looking at? It's not just about reflection, it's like, how does it work? So, in this video, we're breaking down the chemical composition of a modern mirror. At its core, we're talking about the outermost surface, by the way. Uh, when you put your hands in a mirror, you see the gap, right? Yeah, that is the glass. So, at its core, a mirror starts as a glass, also known as substrates. Most modern mirrors use soda lime glass, the most common type of glass in the world. Its primary chemical component is silicon dioxide, or also known as silica, and they usually derive from sands. But pure silica melts at extremely high temperatures, so manufacturers add sodium carbonate to lower the melting point or calcium carbonate to improve the durability and chemical stability. When heated together at high temperatures, around 1500 Celsius, these materials melt and form a smooth, transparent sheet of glass. Glass itself is now reflective. If you only had glass, you'd be looking through it, obviously. So, where does the reflection come from? The actual mirror part is actually a very thin metal coating applied to one side of the glass. Today, most mirrors use silver or aluminum. This thin metallic layer is only like a few hundred nanometers thick, so it's like uh, way thinner than your hair. Here's how it works chemically. The light hits the metal surface, the free electrons in the metal move in response to the incoming light waves and re-emits them. The silver is especially effective because its electron structure allows it to reflect nearly all visible wavelengths evenly, which is why silver mirrors produce such accurate images compared to aluminum. So, how do manufacturers actually get the silver onto the glass? The glass surface is first cleaned extremely well so that metal can stick properly. Then a solution containing silver ions, commonly from silver nitrate, is sprayed onto the glass. A reducing chemical is added, triggering a reaction that converts the dissolved silver ions into solid metallic silver. As the reaction happens, the silver atoms settle onto the glass and form a thin, continuous reflective layer. But there's one problem though. Metals like silver can tarnish. Silver reacts with sulfur compounds in the air, forming silver sulfide, the dark coating you see on old silver objects. To prevent this, manufacturers add protective layers behind the metal coating, like a thin layer of copper to prevent corrosion, and one or more layers of protective paint to seal everything from moisture and oxygen. So, modern mirror is a layered structure of glass and then metal coating, then sealed with protective layers of paint.
Now, let's move on to physics because physics is connected to chemistry in mirrors to produce that reflection that you see yourself. But we will learn about the reflection through technologies because apparently the criteria ask us to explain technologies that we use in mirror or lens. So, we pick the camera. Since we film most of our videos that you are watching with that one. However, in the camera we are using does not have pentamirror because it has an electronic viewfinder, unlike entry level DSLR camera or digital single lens reflex. There are two types of DSLR cameras, the one that use pentamirror and or pentaprism. Yes, there is a tiny mirror in digital single lens reflex cameras, which is are used to reflect the image you'll see when you through the viewfinder. The difference between them only lies in the quality of image they reflect, their size, how they work, and the price. How does the image appear on the camera viewfinder? So, number for the first is light enter the lens. It hit a mirror angled for 45 degrees. The mirror reflect light upward. The light goes into the pentamirror or pentaprism. It get flipped correctly and you see the image through the viewfinder. Pentamirror is a three mirror bouncing the image around, while pentaprism is the one solid glass tunnel that flips the image. A founder of early viewfinder is a single person, but a collective of people whose work contribute the evolution of camera technology, such as an observation the principle of the light made by philosopher that we develop into the construction of the earliest camera obscura by a mathematician, astronomer, and physicist. Ibn al-Haytham, which are later adopted by Joseph Nicephore Nies as the foundation of early camera viewfinder.
And that is all for chemistry behind mirrors.
And physics inside the camera.
Thank you for watching.